Everybody, welcome back. We are working along in our book, and we're going to do something a little bit different this week. We're going to go from a summary point through an entire section. And the reason is this section is about the motivation for DataMesh. And this is a topic we've actually had a lot of discussion in already. And so I'm just going to cover 3 chapters so that in subsequent weeks, hi Matt, nice to see you, we can get to the design, because I think that, we're really all here because of the problem space. So because of that, I'm just going to cover it kind of in a different order. There's 3 chapters, 6, 7, and 8, and it's the inflection point, why you should do it, why to do it, and then why not to do it. And I'm going to go in reverse. I'm going to go at the end of chapter 8, and then kind of use diagrams for a basis of discussion. So we can kind of talk from our experience about why we're here, or really, because it's limitations of current systems. So I'm going to go ahead and share my screen to get started. And like I said, as usual, I'm such a diagram person that I'm going to kind of go from the diagram. So this, again, just to kind of summarize, we're going to, in this hour, discuss the motivation, or why DataMesh. So 6 is the inflection point, 7 is after, and 8 is before. And then they each have a recap, which is kind of a good starting place. So the recap for this entire section is, as it says here, kind of the old ways have limitations. So she says, data has to be extracted from domains and consolidated and integrated into central repositories of warehouses or lakes or both. And this is the key point. This assumption was valid when data use cases were limited to low frequency reports. It was valid when data was being sourced from just a few systems. And in her experience, and in mine, it is no longer valid when data gets sources from hundreds of microservices and millions of devices inside of enterprise, outside, and it's just not scaling because of the amount of data that we're having to perform analytics. So this pattern of microservices is well known and understood for front-end applications, and that's kind of one of the synthesis points of this book, figuring out the application of microservices to the analytics platform. So kind of rolling back a little bit, she talks about something I thought was particularly useful, which is, I know, my world and probably everybody else's, that there is just, if I go back here to this diagram, there is just too many services. So this really is my world. Maybe as a consultant, I don't know if people inside of companies have to deal with this, but big data and AI technologies, and she wrote this before generative AI, so this now has a whole nother page on it. And it is just kind of makes you crazy. So you have to kind of put a hierarchy and some principles on top of it in order to make sense of it. And the other diagram that really hit home for me in this chapter is the one, and I'm guilty of this, of technology-driven analytics architectures. And I felt like, oh, I'm busted. Because as an architect, and this is on page 134, I have drawn this drawing many times, which is basically, this happens to be using Google Cloud Technologies, but it's basically very technology focused. Like, I am working with a set of vendor services, and as an architect, I am going to select the services by purpose, and then I'm going to design for my client an architecture that's very technology focused. And this one really landed with me because, and it maybe is because a long time ago, I actually worked for one of the big cloud vendors. I worked for Microsoft way back when they launched Azure. And maybe this is just something I need to evolve and grow as a consultant, and focus more on solving the problem rather than using the services. But I think somebody might have raised a hand there. So if you want to go ahead and just add.
Yeah, no, totally. And I think I feel so guilty for also, kind of layering on these this diagram and kind of mostly explaining how it would be a central capability. I think one of the points that she makes also is like, when you have this architecture and you're trying to scale it, that these end up being almost like different teams too. So the teams federate around like technology slices and capabilities, right? Which gives you a little bit of scale, but then also creates like, a lot of inertia due to those boundaries. Like, not my job. It's, a feature I'm waiting on another team for, etc. Yeah, definitely reflective of team boundaries as you're first trying to scale a platform like this. Like, you'd have your stream processing team, right? And they'd handle everything in that red circle. And, and then you'd have impedance between them and, kind of the rightmost box, etc. So, yeah.
Yeah. This one just really landed because some of the other stuff she was talking about in here, which is, this is very, how do I say, high level, abstract to me. But this one hit home because I've done this, and just as Elliot was saying, I've designed it first of all, but I've also come in behind when there's a business problem where these data is too siloed, and to come in to try to address that. And so this product thinking is something that I never thought of before. So it is something I'm trying to apply to actually multiple current customer projects. The challenge is to sort of unlearn, because I not only developed in, let's see if I can find the thing here, the old way, the monolithic way. Also, I have certainly developed this way. I think we all have, which is operational data plane, data pipeline, analytical plane, and then visual. I mean, this is sort of the classic OLTP, OLAP. And I not only developed, I wrote 3 books on the topic of OLAP. So, I have to really, really unlearn this kind of thinking, this technology-focused thinking. And that's something that this section is kind of moved me further along. It moved me along of why it doesn't work and what we should not do. And that's one of the reasons that I'm taking these 3 chapters together, because now I'm to the point where I'm actually trying to use data as product thinking, and I'm having difficulty because it's a new type of thinking, right? So she talks about that in the after the inflection point here, aligning everything together, which is easily said, but I mean, this really is a new paradigm. So to, first of all, understand it to a level myself that I can model it and explain it, and then to educate my team members, I'm finding to be quite challenging, because I feel like I'm in the beginning of my journey, and I don't feel equipped. So I'm grateful for the book club here. And like I said, I want to get to the designing, which is the next section, because I feel like, as with all technology, when you get to the point of actually building, then it becomes more concrete. I'm curious if anybody on this call is actually in the place I am, if you're actually trying to start to build a data mesh with anybody yet.
I'm not developing it for a client. I'm attempting to develop a few reference architectures.
Mm-hmm.
And I'm in exactly the place you are. Like I could have given the speech. It's very different. And there's a part of me that wants to sit back into the consulting mode, which is really hard when you don't have an actual client. And just sit back there and use the client. Like, I feel like this is something where you need a lot of domain expertise to do well. And so when I need domain expertise, there's a couple of industries I fall back on that I understand well. They just don't happen to be ones that I'm consulting in at the moment. I'm learning, but it's been a challenge, because what I want to do is I want to sit down with that domain expert and say, can we do like a 2-hour whiteboard session so you can tell me what data products look like in your domain? What do data products look like in manufacturing, for example? Because manufacturing, I think, is actually one of the places where this is going to live very well. IoT, manufacturing, bringing all that stuff together. Each of those is a data product that the different teams can deliver. And many times in manufacturing, each subsystem in a factory that would be a data product is managed by its own team.
Right, right. Well, again, you know, she's giving a lot of high-level drawings around her example, but the example doesn't stick with me very much because I don't work in streaming music services. And so I need to rework the example, just as you were saying, for my customers, which are, you know, bioinformatics. And the translation process between the music domain and bioinformatics increases the cognitive overhead when I'm trying to use the new concept. So what I typically do is, what you do in anything, try to get a minimum viable. And so I'm really kind of thinking about, okay, is it a data lake that has a set of services? Is that what the minimum viable looks like for me? That's kind of what I'm thinking, because this mesh is like, you know, a lake of lakes with databases thrown in for good measure, or analytic stores thrown in. Go ahead.
Oh, I didn't want to interrupt you. I was just going to add our story to that a little bit.
Oh, please do. You're not.
Oh, okay. So we're at an interesting time, and Jason and I have had a couple of phone calls as he's schooling me on what Azure is, because we're Azure Fabric, because we're a Microsoft shop. I'm trying to figure out how to put this in our situation, and I think one of the difficulties with us is 95% of the data requests come to the IT department. And so we're the data team that puts it together. Also, I would say 95% of the requests are all handled internally on Microsoft SQL servers, Excel spreadsheets. You know, there isn't a lot of other things out there. We've got about 100 Power BI reports now, which fortunately are pretty much all done by one of our data research people that's an entirely different team. So there's someone outside of IT who really loves to dive into data, and he's really good at it. The really cool part about that I'm excited about is we are now starting to move a lot of our servers off-prem for scalability, security, and other things like that. We don't have a large staff. We don't have a ton of engineers. There is no way we could have 2 or 3 engineers who do nothing but pipeline ingestion thinking. We're jacks of all trades. So one of the reasons why we're trying to offload a lot of this stuff into the cloud is to get rid of the low-level maintenance work that we're currently doing, so that we can spend more engineering thought work on developing systems for schools. So getting SQL databases off of our on-prem SQL servers into Azure SQL in the cloud, so that we're not having to do backups and Windows updates and all these other things. We can actually build databases. Now with our other gentleman involved, we've got things in the cloud now. We've got things on-prem. Our data sources, for the first time ever, really are living in multiple places, and a lot of places that we don't have control over. So I'm really excited about pulling all that data into something like Fabric. We're like, hey, this is where you go. Oh, this is actually hosted by another company, and we have a SQL connector. Oh, this is actually hosted by another company, and they use an API. Go to one place, get the data in, and here's our SLAs on how often that data is refreshed. And then the other thing too is he's really finding out that with 100 Power BI reports, some of them take quite a long time to process because he's hitting so many things. And he's being a good steward now, where he's starting to play with data flows. Let me pull the data once and then serve that up to 20 different reports. And so now we're having all these conversations on Fabric. Wait a minute. Microsoft just came out with this new thing that used to be this old thing over here. Now you can do it here. It lives in the Fabric. Maybe we can put permissions on the low-level data layer rather than putting the same permissions across 80 different reports. So we're having those conversations. So I think we're kind of there with you. We don't have the big architectural model old school. We certainly have the mentality of everything's in a single database and everything lives on a SSIS, ETL pipeline. So handling that in the cloud and what that means, I mean, it's really opening the door for us to think about a lot of real-time things that we can do. Why are we batching 20,000 kids every single night and creating Google accounts and permissions and all these other things? And similar with special ed data and other stuff, once a night when 2% of the data changes. And then we come to a new school year and 80% of the data changes because a lot of the kids are moving to different grade levels, having different programs. What if we batch it and the kid gets registered and literally by the time they walk out the door, their Google account's already created? Same thing with HR, things like that. So I'm really excited about where we are. The other kind of thing I'm excited about too is some of the old tools I was looking at even a year ago or 6 months ago. Microsoft has said, hey, by the way, we revamped it. You now do Power Query as your ETL in Fabric. And I'm like, yay, because I love Power Query and Power BI, but doing everything in SSIS it would have been a struggle for my team. So it's really neat that they're putting a lot of these new ideas and they're coming out with them so fast. So
Yeah,
so
I want to just call it a couple things you said there. Moving to the cloud basically allows your IT team to work at a higher level, and Amazon calls this the undifferentiated heavy lifting. That's their famous phrase, but like the backups and all that stuff, so that you can work closer to the data. So that's kind of a baseline thing. Getting more of the data in your case, cloud. It's often going to be cloud services, so that the baseline tasks are offloaded to the cloud vendor. So that's one thing. Another thing that I think is a big aspect of this is figuring, and this is one of the ones I'm struggling with right now, figuring out what the paths are so that the domain data users can self-serve the data, because that is a really different thing. But in these resource-constrained times when the IT folks, even working at a higher level, have more data to work with, it's part of this. So somebody else has a hand up, so go ahead.
Yeah. So agreed. I think the part that's most kind of immature is the self-serve, some of this Envision portal. But kind of backing up a little bit to the MVP and also a little bit of my experience in trying to do something like this. So to me, the MVP is these circles, which is actually more like process change, right? That you are going to create distributed publishing and kind of like distribution of data, right? Creation and distribution of data outside of that central data team. So instead of the data engineer thinking like, oh, how am I going to package this thing and make it available for 20 reports, the team that owns that particular data set is actually figuring out, hey, how can I make this data good for everybody and enable consumers, by its publication or its distribution, right? So to me, that's the MVP. Like, if you don't do that, I don't think we've achieved very much, because it's all still very central, right? So and the distribution channels are there. They're not beautiful, and they're not, like, I think, as envisioned, right? Like, the most practical thing, which honestly I've done when I've, for years and in kind of like this evolving thinking, is think about, the good old AWS Glue Metastore, right? You register data sets and people can go pick them up and, kind of import them into the Redshift cluster or use them in Athena or whatever. And there's a catalog and a contract for how they're going to continue to do that. And from what I hear, that's kind of like the way things work in AWS. They have like a souped up version of that, and Amazon proper, rather, which I guess is, we get the more dumbed down version of it. But yeah, to me, the circles are the important parts, the people becoming producers. And in terms of wrestling with this, I'll in the real world, my last company was super engineering focused, right? And we had distributed kind of like squads. They owned products. We actually started making the circles, right? Like, hey, you guys are not just like responsible for product features, but you have non-functional requirements to produce data for your other services. And we were a microservice shop, so producing data wasn't just an analytic concern; it was also for like functional concern, like across the services. So we got somewhere. We really got somewhere, and we did layer on a certain amount of like the data distribution concept as well, and we built tooling to enable people to publish events and apply quality assurance to events and register to a catalog and all this kind of stuff. So we got somewhere, like some gradient of this. Now fast forward, I'm working consulting with a major retailer who's not an engineering company, and their tendency is to go central. And I'm having all sorts of like thought-provoking conversations about building those circles, right? My thesis is it nets even, if you make your teams like data producers in the long, strategically and in the long term, but people still want to pull up that curtain, have you jump into their database and just pull it out, or have no concerns of data at all, just to focus on the products and the tools that they're supporting, right? So last company, some success. We got somewhere. This one, it's challenging, but I'm trying to fight the good fight.
So again, not to just spend the entire time on these circles, but I obviously they resonated with everybody. I just want to point out that it includes the business objective, which this is again another technique that I'm trying to use in determining how to model these and make these and educate people about these. So, listener, the business objective is to grow listeners. Partner, the business objective is to create an integrated experience with partners. The player is an increased listener engagement. So all measurable metrics, because all businesses run on metrics. And, the metrics change when the model changes. So a couple of things Elliot was talking about that I want to just call out there. He was talking about closing the gap between analytical and operational data. And it was a very interesting discussion. Again, back to the structure of the org is the structure of the software, Conway's Law, right? So when he was in the microservices shop, he was able to move more towards a data mesh type architecture because data mesh is microservices, it's for analytics. And now he's in the monolith shop and he's finding it a tougher go. And that's kind of where I am too. Because how you close this gap is dependent on how people work, right? So if they're working in a way that's monolithic, it's going to be a lot more difficult for them to start to work in a correct way. And then one more thing, and I'll let you guys jump in, that I heard in the discussion is this localizing data to the business domains. This is something in the world of cloud that there should be like big flashing lights, because we all know that one of the ways cloud vendors make their money is by egress charges. Like they charge very, very little, especially for file-based data systems, lakes, to suck the data in, because they want you to bring the data in. But when you have these complex microservices architectures, you're going across boundaries, which could be across cloud regions, across cloud vendors. They could be cloud to on-prem. So you have cost, but you also have bandwidth considerations. So one of the things that I'm being challenged is overwhelming the pipe, moving to this, going back to on-prem, implementing this microservices architecture, because it's not so simple to localize when you're in a hybrid world. So I don't know if anybody else wants to make any comment on that.
So the only thing I'll say is to step back and say that there's also an organizational conceptual component, which is there's a lot of organizations out there that are built on functional lines rather than the idea of cross-functional teams. And I don't think that you could successfully build something like this on functional lines. I think that the idea of cross-functional teams has to come into play Because if you're not going to be able to get a data person at least time shared to every team, they're not going to be able to successfully do, like a team of document publishers is not going to necessarily be able to create data on their own unless they've got that skill set somewhere. And so you have to build the cross-functional teams rather than the functional teams. And I think that that's an important lesson here. And it does come back to Rome as well.
100%. Somebody else has a comment?
Yeah, so when we are talking about the old school monolithic way, however, it seems like, you know, it should be just going off, like retiring this complex system. But when today I see in the current situation, they are using many applications just to fill up the gaps. You know, there are two things: something is not here, another application, any API is coming in, you know, picking up the data from here and there and then producing something new. Good enough. But the challenge, what I see is, again, the drawing boundaries for it, the proper utilization of data, which is being fetched here, fetched from B domain, C domain. Like they are ready, they are utilizing it as something, but rest of the data is kept lying. So either they have to filter the data here, what exactly do they need? Not like whole bunch of A, whole bunch of, I mean, it should be just very sensibly being subset. I don't see this situation as helping. And when I ask for the permissions, when I ask for what is my premises, so it's a very general answer. We have to be courteous. Courteous is just on me. It's not profile. My user profile is not restricting me anywhere. It is only my mind which is restricting. So I have a full privilege. I see this is actually a mess rather. You know, when lots of things are, it's okay to utilize lots of APIs, many different other systems to get this useful data because I need this part. Maybe B team needs another part. But what if other things are being exposed, any other sensitive data has been exposed, not been utilized, it's just kept lying. And moreover, I'm not suppressing it anywhere. I'm not restricting the users to see them. I'm really worried on that. I don't know, maybe going forward, there is something which is coming up to help that. But now when I compare, I see monolithic way, at least that is giving me a complete right rule to do this, where my whole boundaries are here. Team B has its own boundaries. If we need to communicate something, it is with someone from any SPOC from team A, any SPOC from team B. So this is not secure somewhere. That's what I see right now.
Yeah. So just a couple points before I let other people jump in. So that's a nice lead into this accidental complexity. So, and again, I'm finding this, right? And it goes back to what Jason said about you have to be a domain expert, which is no trivial thing, right? Because if you come in, especially as a consultant, you're not an employee. You have to find the domain experts. You have to partner with them. You have to learn about the domain, and then you have to teach them about this idea as data as product. And again, just because I think we need a little levity, we've had this serious discussion. I'll just ask everybody around, but I'll start here. I actually know Fred Brooks, so it's kind of fun to see this. No Silver Bullet, Essence and Accident in Software Engineering. Good paper, by the way. He has lots of talks on YouTube. Two types of complexity. First, we have the essential complexity that's essential and inherent, and then the business and domain, then accidental. That's probably more than what we do, and copying data. So I have to tell you, this is an actual true story. So we'll see, we've got a lot of consultants on here. And it's a long time ago. This is the beginning of big data. I got called in to work on a big data problem with a company, and they were, to Varsha's point, they were in such disarray before all this that they didn't even know. And after my 1 week, 40 hours, one of the artifacts that I produced was how many, ready for the cringe, non-synchronized copies, so partial, you know, just the complete mess Varsha was talking about. How many copies of their analytics data did they have? 9. They had 9 copies. So I just want to put out there before I open it up for more discussion. Have any of you seen more than that? I think I probably win here. Anybody had more than 9?
Oh, I think you won. I maybe 3.
9. I'm not even kidding you.
I want to differentiate that, like, it's in this, it's okay to have copies of data, right? But
Right.
these are like disparately populated, different definitions, not aligned. Yeah, that's the record, I think.
So anyway, so I know some people had their hands up. So what do you want to add here?
Well, I just trying to go back to making it practical. So you can give spoilers if you want, because I haven't finished the book, and she's talking about after the inflection point. But where do we go from here? So I'm thinking the 2 pizza box mentality. Don't have a team larger than you can feed with 2 pizzas. So I'm thinking, okay, you have your product team, and then you got your consumers. Some other team needs their data. Well, can you get 5 people in a room together to solve that problem with this? And I think one reason those architectural diagrams came out is because we realized we were in a mess. You got 20 different people doing overlapping things, and you create this mess. You have your sprawl. You've got your data everywhere. Some of it is well tracked. Some of it's non-qualified. Some of it is completely open to the public, and it shouldn't be. So we created standards, and we created patterns around that, right? And our patterns grow in complexity to the point where, oh my gosh, now there's 20 different items in your standard architecture. We got away from your. So I'm wondering, okay, we still need ETL, and we still need governance, and we still need data validation in order for this product to be usable. Is the idea that, okay, but my product team should incorporate 1 or 2 data people, and between them, if you are only creating a small product, you're not creating a data lake for the entire organization. If you're creating some product, can that be left up to 2 or 3 people who have the domain knowledge so they know exactly what they're doing? And we teach them the basics. You have your code camps or whatever you want. I'm hearing these days of pizza box, teams. Instead of having a 100-person development team, you now have 4 or 5 developers with your engineer and with your data people, your design people, your business people. And you teach them all how to do normal front ends and back ends. You don't need one giant monolithic back end for the entire company. You teach them how to make it. And then you have these small little tools, very agile tools that do exactly what they want to do and no more. But they're built robustly to the company's standards. I'm wondering if that's where she's going. And the only other thing I'll add to that is one reason why we have these complex architectures is because we said, oh, we need one place to store everything. Here's the architecture. Oh, wait, but I want it to do this. Oh, now I have to do another level of abstraction to handle all the edge cases. Well, what about my ingestion? Oh, now I need another level. And then you end up with this monolithic architecture because it was supposed to do all things for all people. If we get back to the pizza box mentality, maybe our architecture diagrams get much smaller because you only need the specific pieces you need for that one product and no more. Is that where we're heading?
I think so. I mean, again, this leads very nicely into sustained agility in the pace of growth. And the very first thing is remove centralized and monolithic bottlenecks. So literally turn your monolith into microservices. I mean, I think pretty solidly that's the concept. The question is, what happens here? What's this arrow? Because you don't just start chopping, right? How do you define the circles, right? So
actual brainstorming is here.
Yeah, well, I think the way typically is you slice off a piece, right? I mean, if I go way back when I created data warehouses and data marts, I very, very often would create what I'd call it a small cube. Sometimes when I was very sarcastic, I didn't say this to the client, but I'd call it my boss cube. So I would create a little data mart just for the CFO because I was not dumb, who's paying the consultant's check, right? So you create a little subset, because that's simpler to do. And then you can actually federate the data marts. So, I mean, this isn't like a completely new idea. The difference is the underlying technologies that have proliferated. In those days, 10 years ago, 15 years ago, the underlying technology was OLAP, right? And now it could be a data lake, it could be an event stream, it could be a whatever. And to go to Matt's point, are the diagrams smaller? Yeah, I think they are. I think that each one of these is a diagram. That's the way I'm designing it. Because, and I'm not saying that this team can't see this team's diagram and there won't be some patterns. There should be. There should be a patterns repository that you start from. But then there is a customization component. It's a configuration. And that goes to really what her next step here, which is reduce the coordination of data pipelines, which what she's doing here is instead of one big pipeline, the way I take this is operational, this is a ETL, this is your groomed or your analytic data. And then if you go downstream, you have a contract here, and this is the microservices. Go ahead. So somebody has something to add?
Oh, sorry, I was on mute. Yeah, so I think first I'm gonna back up like a lot. That's why I like this call, because I think like I just internalized that, and I knew this, but I think like unless you're working in business domains, like in squads, this will never work, right? Because yeah. So just a little statement. I knew that. I like, you know, I think yeah, I'll have to fight that fight, and I hope to instill many of these principles in my current engagement. But anyway, yeah, I think that's right. You know, this diagram that they're internal pipelines, and I think the internal pipeline tools we don't actually care about, right? Like I think those don't need to be standardized. It could be fit for purpose. But I wonder, like, do you guys feel that there's any way that this could work unless you did standardize the data sharing and distribution channels, right? Like, I feel that those do, you know, and I think she makes that case as well, that there's probably only like a handful of distribution channels that are viable to do this kind of thing. And like, they'd have to be standardized within an organization.
Well, just before the next person jumps in, again, you guys are just following the outline. Thank you. So here she's talking about reducing the coordination of data governance, okay?
Yeah.
This is some pretty words that are very, very hard to implement. And if you remember from previous weeks, I talked, and I don't really like that drawing. Yeah, I don't. I actually talked about policies as code, and I showed with the example of Google Cloud, the concept of an organization with organizational policies and then folders underneath it that have differing policies that are less open than the top level, which is the central restricted. So you can have different levels of openness, if you will. So the idea is that you have some non-negotiables, but that you reduce, as she says here, you reduce the number of them. So you challenge them harder. So that's what I have found in practice, was what it is.
Yeah.
So to translate it to something that's a little bit more consumable, because I'm literally doing this, you go to the org policies for your particular cloud hierarchy, and you review the org policies and you say, is this providing the business value? And one of the, I mean, just from a very tangible point, one of the situations I have found is there has been perimeter control around certain data products, and in my case, they're types of Google Cloud projects that aren't really effective. Because if you actually know cloud, if you prevent download from one service, but you don't prevent download to your desktop, let's say, from another service, you can copy. So what are you, like, the literal thing is if you have a allocated space of a VM and you don't allow downloading locally or egress from the VM, but you don't block copying to a bucket, and then you can download from a bucket, you're not protecting anything.
Yeah.
You're just making the user's life harder, right? And so going back as part of this data mesh process, and because that's literally some of the work I'm doing right now, and going, okay, I would like to see all the organizational policies. And in some organizations, that process requires clearance because there is an aspect of, in high security environments, the security configuration is actually only revealed to a very small amount of people, which, on purpose, right? But somebody, when you're modeling the data mesh, needs to make an effort to reduce this coordination. It's not going to happen magically. And the process of reviewing the organizational policies and making the security team explain, testing them, and making sure that they're actually providing business value is some work that I think is foundational. Because you can't delegate if everything's locked down. Do you know?
Yeah.
This was the most frictional part, because explaining the policies, what you really think is suitable for this certain area, and what you don't want to inherit, what you want people to follow, and educating people, I mean, the users for this is like way challenging.
Well,
When I see things, I mean, till now, since we were just going through subject, and now when I see the implementational part of it, I really find this thing, there is a gap. There is a good gap.
Well, it's interesting, again, taking a pattern from microservices application architecture and applying it to data mesh. We've had some discussions with my client about this, and this is really interesting, that and Elliot would know this really well, in microservices, there's a concept called observability, which is you're just basically looking, examining the state of the currently running system, and then you've set alerts, and you're getting alerts on certain, like if you're running out of resources in the cluster or whatever like that. So it's more of a observe and respond rather than block.
Yeah.
And the concept that we're moving towards is it's just too difficult actually to implement lockdown policies across these increasingly complex analytics solutions that don't do what I just said, that kind of just make it harder for people and actually don't block anything. It's very difficult to set that up. So rather than setting that up, tend to, as open as you can be, clearly articulate what the rules are, and obviously you have to meet any legal compliance, and then set up observability and respond to events, which that is a big change. The old data days is lock it down. If in doubt, lock it down. And I don't know how long it'll take before that moves, but that is part of this, because you can't have a data product if you can't get to your data.
Yeah.
So anybody else have anything to add here? I've been kind of going on a little bit. No, okay. All right, so then they just talking about autonomy, right? So you basically going to have to, as Elliot was saying, you have to have the right team. As I've been talking about, you have to have the ability to get to the data. And the sort of the where we want to get to is self-serve. And again, how do you self-serve data? Do you have to build custom applications for each thing? Can you do it through a system like Power BI reports, or Looker if you're on Google Cloud? How do you do that? What computation do you put with the analytics data to make it available? And this is one I'm running into quite a lot. In a data lake scenario in the cloud, you put your data in buckets. Well, cloud services are designed, many of them, to work with buckets. But custom analytics tools are often designed to work with attached storage, which is substantially more expensive. And so, this is different in different industries. Some industries that have been cloud native longer, like finance or advertising, everything's cloud native there, or much of it. But there are lots of industries, healthcare, government, like infrastructure type stuff that has non-cloud native. So how do you take all those analysis tools that are designed for being installed on a server that has locally attached storage, and how do you make those things self-serve? That's more of a question than a information. That's a question I'm thinking about. Do you have to rewrite all of them? Should there be a data layer? Like, how does this happen? I don't know if anybody has any insight on this, but I would welcome it.
If you refer here, this situation, what we're thinking of, probably there was a self-serve platform, which you remember in the previous chapters we have learned that. If we think of that scenario here, probably it would be more fruitful, and that is more implementable here. When we have just one platform, 2-3 people, I would say in this scenarios, teams should be really small, not big, precisely keeping like one engineer, one business team or something who would just pull in the idea, where there, the perception is single, because the more the people, I find more the confusion then. When you a smaller section can easily be built up here, which will give you the more fruitful, as Elliot was saying, that data is functional, then it is more like a product. Then that can be used, and I think that can be easily ingested in any system. It's just like plugin.
Well, the question really is, like in microservices, you make APIs. Like that's the way that was solved. So is it just as simple as you make API? Like that's part of the pattern? Like, again, this is a question I'm asking myself. Like, do you just say, well, in every data product, we're just going to expose it as an API? Like that's just what we're doing, like a microservice. Has anybody given any thought to this? Is that something they would be considering?
I think it could. Oh, go ahead. You go first, Matt.
I'd say for us, we've been dealing with this over the last several years, where most of the vendors and stuff we buy from have no concept of sharing data outside of their system. Their intellectual property is the way that they analyze data and give us reports. And when we started to say we want our data, they were like, why? Here are reports. Here's the dashboard. No. We want to merge it with our own data and create our own data dashboards and analysis. And they couldn't understand the concept. And so we've started to, as much as we can, guide people to buying data services that offer APIs and ways for us to get data. Now, the other problem beyond that is, okay, well, now we're holding 2 copies of our data. We're spending a lot of money for a company to create this really great service. And then if it doesn't do everything we want, we're downloading enough data to make use of it. So now we're paying for 2 copies of it. Okay, but you can't get around that. As far as making it, so that's that. As far as making it self-serve, I think the biggest problems with that is we don't have a real, at least I haven't seen, maybe they're out there, a really nice, intuitive, non-technical tool to find the data and make use of it. And so I was on a phone call with a company a couple of days ago who are offering a data service. And they said, Matt, no one ever had to teach anyone how to use eBay. Everyone, you go there, oh, I want to search for an item. Oh, here's some cool, how do I create a bid? Oh, I added a bid, stuff like that. Oh, I want to sell an item. Sure, there's a few help docs. Maybe you had someone come up and help you. But for the most part, no one had to do that. And I thought, you're right. I'm able to find what I need. I'm able to validate it, read about it, make use of it. Where is the data store? So if we create these products, and you've already talked about some tools out there, but are any of them any good where I could have a business person, a non-technical person, open some sort of tool and search and find the data they're looking for in a very intuitive format that makes sense to them in their context? And then how do you make use of it? So I talk about Power BI. I'm sorry, we're in a Microsoft shop. I don't have access to $100,000 Tableau or all these other things. But I grew up in the days of SSRS and active data reports and old things, crystal reports, and now Power BI. I still think Power BI is too hard to use for a non-technical person. I can import data with the best of them. That's great. But the instance, I need to do, if I can do it in Power Query, I think Power Query is very intuitive. It's very graphical. Their icons, their flow, I think is really intuitive. They did a really good job. But the instant you tell me, oh, you now have to dive into their M language. Oh, you want to do that in R. Oh, you've already lost 90% of the business team.
True.
So can we create a Canva, a whatever, a really nice, a TikTok version, whatever. I'm being facetious, but really, can we create an app that allows business people to find data, throw on some charts and graphs, some easy reporting without having to dive into a query language? I think once we find that, and if it exists, please let me know. I think that's where the self-serve will come to, because
Yeah. So I have a couple just a second, Elliot. I have a couple thoughts there. The first thing is relational data has that kind of approach. But then this problem, I just want to be inclusive of lakes because it's a harder thing because you don't have basically a tabular structure. So, Elliot mentioned it, and then I did previously. In order to build this mesh product, suite of products, you have to have a metadata store. Also, there are these new service planes, Microsoft Fabric, Jason talked about. Amazon has their thing, Data Zone, and Google has Dataplex, is the beginning of this. And I showed that in previous talks, and I'll be showing it again. The thing that I think is interesting, and it seems like every call I have to talk about this, but it's the time, is I do believe that large language models have now evolved search and technology to the point that English can be thought of as a coding and query language. And there are foundational models that make it partially workable now, but of course we all know they hallucinate, so they're not a full answer, they're a starting point. But Microsoft, for example, has been showing LLMs with the SQL Server query plane. And I think I talked about this as potential solution where researchers didn't know SQL for BigQuery. So I think that as LLMs are customized to domains and trained with domain data so that the domain English, so in my world, bioinformatics English, or in Matt's world, K through 12 school English, is the basis of the LLM. I think that's actually going to get solved pretty quick. And I think that's going to impact the self-serve capability. I think that English is going to be the query language. And that's kind of interesting to me. But I think that building those LLMs might actually be part of building data mesh solutions.
Yeah.
That's interesting. So I too was going to think about like the now and the future, right? Like, so I will say that I think now, and I've been like fighting this battle for like a while, like y'all got to know some SQL, right? Like the and I know all the pitfalls of that, right? But I think like, analytic professionals, people who consume analytics do need to know a little bit of SQL. But as Lynn was just saying, I think the rules have changed in the past year and a half, and I think things will evolve pretty quickly where, English language is going to become the query language, or, make it a whole lot simpler to get this data. Yeah, I forget what the other thing was that I wanted to talk about.
That's
so let's move on because we don't have much time.
Yeah, so I actually just kind of want to wrap up
on
and
LLMs.
and I always have to talk about it, right? And kind of go into what I think is, not that what we've covered isn't important. I think it is. I think it's a mind shift, and us working together helps us as leaders educate ourselves, challenge each other, and get ready to educate others. But the pedal is hitting the metal here in the upcoming part, which is We've got how to design the data mesh architecture. So those are the fundamental services around the data mesh. So to make it very concrete, that would be, in my world, like a GCP organization with organizational policies that relate to data mesh and services. And then once we get through those 2 chapters, then it will be how to design data product architectures. So I'm really looking forward to getting into this. And I just want to kind of throw out to the group that partially it's driven by my actual consulting work. I'm supposed to be making one of these. So I'm going to kind of amp up my work with this. I was kind of playing around with Dataplex, but now it's time to try to build something a little bit more closer to the actual problem space. And I really would welcome if anybody else wants to build anything, if you have time, that you can show, obviously. So I'm going to go ahead and take next week's chapter as a lead, and then we'll kind of just go as we go. In my perfect world, we would have something from Fabric and something from Data Zone. And if we even want to look at samples, you know, if you want to take your cloud that you're interested in and pull samples in, just because I want to switch now more into the, okay, we get it, we get the problem, we get what we want to do, how do we do it?